Okay, the radius of a circle is increasing at a rate of 5 centimeters per minute. So the radius is increasing at this rate. So the rate at which the radius is increasing with respect to time is 5 centimeters per minute. A says, how fast is the circumference of the circle changing when the radius is 10 centimeters? So A wants to know the rate at which the circumference of the circle is changing with respect to time. And it wants to know when the radius is 10 centimeters. So when radius is equal to 10 centimeters. Okay, so what we need to do for A is we need to have a formula that is going to relate radius and circumference. Does anybody remember? I don't know if it's actually on your, what's the circumference of a circle? Yes. So the formula that relates the circumference of a circle with the radius is the circumference of a circle is equal to 2 pi r. So again, come up with a formula that relates circumference with radius. Then you put in anything fixed in here. Nothing would be fixed in a circle. If the circle is either getting bigger or it's getting smaller, nothing is fixed. So what we're going to do is we're going to differentiate both sides implicitly with respect to time. The derivative of c is 1 dc dt. The derivative of 2 pi r is what? It's 2 pi. And then we just took the derivative of r, so dr dt. Okay, so we need to find dc dt, and that is equal to 2 times pi times dr dt. We know what dr dt is. So the rate at which the circumference of the circle is changing with respect to time is 2 pi dr dt, which is 5. So the rate at which the circumference is changing with respect to time is equal to 10 pi. And what would the units be if it's circumference? Centimeters per minute. Yep, that's the rate at which the circumference is changing. Okay, B says, how fast is the area of the circle changing? So how fast is the area of the circle changing? So they want the rate at which the area is changing. So that would be dA over dt. So the rate at which the area of the circle is changing with respect to time. So this is what they're looking for. When the radius is 8 centimeters, so they want the rate at which the area is changing when radius is equal to 8 centimeters. And they had originally given me in the stem of the question the radius of the circle is increasing at a rate of. So they gave me dr over dt is 5 centimeters per minute. So dr over dt is 5 centimeters per minute. Okay, we need an equation that's going to relate the area of a circle with the radius of a circle. What is the equation? What's the area of a circle? Pi r squared. So the area of a circle is pi r squared. Nothing is fixed. Differentiate both sides with respect to time. So the derivative of A is dA over dt. The derivative of pi r squared is 2 pi r dr dt. I'm finding dA dt, so that's already isolated. They want when the radius is 8, so this is going to change to 8, and dr dt is 5. So the rate at which the area is changing with respect to time is 2 pi. They want the radius to be 8, and they want dr dt is 5. Okay, so from here, 2 times 5 times 8, or 2 times 8 times 5, what are you getting for that? 80. So the rate at which the area is changing with respect to time is 80 pi. This is an area question. Area is always squared. So the units were centimeters. So it would be squared centimeters, or centimeters squared per minute. So the area of the circle is increasing at a rate of whatever 80 pi is, centimeters every minute. It's getting that much bigger. Okay, we need to add this question because I don't think they're in your note packages. So the two questions that we aren't going to do, so you could cross those out and choose one of them for this. So the surface area of a spherical melting snowball is decreasing at a rate of 2 square centimeters per minute. Find the rate at which the diameter is changing when the radius of the snowball is 5 centimeters. So the surface area is decreasing at this rate. So that would be the rate at which the surface area of the snowball is decreasing with respect to time is 2 squared centimeters per minute. And because it's decreasing, this rate would be what? Negative. Okay, next it says find the rate at which the diameter is changing. So they want me to calculate the rate at which the diameter of the snowball is changing with respect to time. And they want that when the radius is 5 centimeters. So when radius equals 5 centimeters. So first of all, if the snowball is getting smaller, it's decreasing, it's melting, would we expect our diameter to be a positive or negative number of the snowball? Yeah, the diameter should hopefully be a negative number. Now, this is going to be considered a new question from what we've done before, even though we've done a melting snowball, and here's the reason why. Students will be like, what is the formula that relates surface area to diameter? Because that's what we always need to figure out, is a formula that relates these two. Now, write down what the surface area of a snowball is. You guys should know what that formula is. So look into your notes. What was the formula for the surface area of a snowball? 4 pi r squared. Okay, the formula that we use needs to relate these two variables, surface area and diameter. So somehow I need to change something in here. And it's going to have to do with the radius. I could actually take radius out and somehow put something to do with diameter in there. How are radius and diameter related to each other? That's right. So let's jot that down. The diameter of the snowball is twice the radius. Okay, so the diameter of the snowball is twice the radius. If I want this formula to reflect surface area and diameter, let's take r out. I could solve for r within this equation. What would r be equal to? So diameter is equal to 2r. What would r be? That's right. Divide this by 2 and divide this by 2. The radius is d over 2. So I need to always relate these two variables. Let's take radius out, and radius is the same thing as diameter divided by 2. So the surface area is equal to 4 pi d over 2 squared. Let's clean this up. The surface area is equal to 4 pi diameter squared over 4. And then 4 over 4 will cancel. And the surface area is equal to pi d squared. Okay. You guys, we could also change one thing because now I've related surface area to diameter. They want me to calculate when the radius is 5 centimeters, but I no longer have radius is 5 here. So what would, if the radius is 5, what diameter do they want that at to be? 10. So they're actually, because I got rid of radius, I now know that the diameter is going to be 10 centimeters. So I'm calculating when the radius is 5, which is the same thing as diameter of 10. And I want that because I've created my formula to reflect surface area and diameter. So now that I have that, we're going to differentiate both sides with respect to time. So I get the rate at which the surface area is changing with respect to time is 2 pi d, and then the rate at which the diameter is changing with respect to time. From here, the surface area is decreasing at a rate of 2. So I'm going to put negative 2 is equal to 2 pi. Diameter, we just said, would be 10 now. And I'm looking for dd over dt. You could multiply 2 times 10. Do you see how the 2's would actually cancel, though, on each side? So if you don't see that, that's fine. I'll just say, okay, I've got negative 2 here. And to get the rate at which the diameter is changing with respect to time, I'm going to divide both sides by 20 pi. 20 pi. And then 2 goes into 2 once, 2 goes into 20 10 times. So the rate at which the diameter is changing with respect to time, it's going down, the diameter is decreasing at a rate of negative 1 10 pi. And what would my units be? Diameter is centimeters per minute. Okay, so the next two questions that we're going to do with cone, it's going to have this sort of similar strategy where we're going to have to manipulate something within our equation. And that's where it becomes one level of difficulty greater because there wasn't a formula right away that related these two. So we have to actually think about that. Okay, so let's look at the cone questions. Here's what happens with the cone questions. Imagine that sand is falling off a conveyor belt. And what would happen is the sand would pile up in a conical shape, right? If you have a whole bunch of sand just falling onto the ground, the sand would eventually form like a conical shape. And so it says sand falls off a conveyor belt into a conical pile at a rate of 2 meters cubed per minute. What rate did they just give me? If it's in meters cubed, that's the volume of this cone. So the rate at which the volume of the cone is piling up, so the rate at which the volume is changing with respect to time is 2 meters cubed per minute. The radius of the cone is always twice the height. So we're going to have to use this piece of information somewhere. So the radius of the cone is always twice the height. So what they're telling me here is they're telling me that the radius of the cone is always twice the height. So if the height was 10, then the radius would be 20. Okay, so the radius of the cone is twice the height. We're going to have to use this somehow. How fast is the height of the pile increasing? So they want to know how fast is the height increasing? So dH over dt is equal to, so they want to know how fast is the height of the pile changing with respect to time when the pile is 4 meters high. So when height is equal to 4 meters. Okay, so we need an equation that's going to relate the volume of a cone with height. What is the volume of a cone? volume is equal to 4 over 3 pi r squared h. Okay, so far we're in good shape because, wait, is it? 1 over 3, thank you. 1 over 3 pi r squared h. Okay, so far I do have a formula that relates volume and height, which is good. So I want my equation. I need v in here, and I need h in here. If I take the derivative, implicitly derive this, I could use power law, or sorry, product law, but then I'm going to have like r in my equation, and I'm going to have dr dt. So is there a way that I could actually get rid of this radius? I need volume and I need height. Can I somehow use this to get rid of radius? What would it be? Take out r and put in what instead of r? 2h. That's right. So take out r and put in 2h. So volume is equal to 1/3 pi 2h squared times height. Okay, let's see how this will clean up. Volume is equal to 1/3 pi. This will be 4h squared times h. And this will be volume is equal to 1/3 times 4. Oh, that's where I got the 4/3 from, I guess. This gives me 4/3 pi h cubed. So now I have a formula that relates volume and height. And I'm going to implicitly derive both sides with respect to time. So dv over dt, the rate at which the volume is changing with respect to time. If I take 4/3 and I multiply it by 3, Maya, what are you getting the derivative of this guy would be? You do power. So 3, yeah. So you get 4 pi, and then what would be the h? H squared. And then we just took the derivative of h, so dh dt. Okay, I'm looking for dh dt, and I was given dv dt. So dv dt is 2. They want the height at 4 meters. So height is 4 squared dh dt. Instead of doing 16 times 4, I'll show you how you could do this. I've got 2 on the left, and you know that we're going to be dividing it, right? So instead of doing like 16 times 4, I know I'm going to be dividing that out. So 4 times 16 pi. Are you okay with doing this? And then the reason why I'm doing that is because 2 goes into 2 once, 2 goes into 4 twice, and then I could just do 2 times 16 to give me 32. Right? So I just, what I was doing, I divided this side by 4 pi times 16, divide this side by 4 pi times 16, isolating dh dt. So the rate at which the height of the cone is increasing with respect to time is 1 over 32 pi meters per minute. Okay, let's do one last one. Again, it's going to be similar. This one would be the most complex, but you have a hint. The same hint would be on your test. Okay? Same thing is happening. Sand is being poured from a conveyor belt, and it forms a conical pile where the diameter is equal to the height. So let's write that. They're giving me that piece of information probably for something. So diameter equals height. Diameter equals height. If sand is piling up at a rate of, write what rate they just gave you here. Oh, and what did they give me here? Sand is piling up. Did you say DH? It wouldn't be DH because this is meters cubed. Yes. So this would be the rate at which the volume is increasing with respect to time is 0.5 meters cubed per minute. Again, how you can figure that out is by looking at the units, right? At what rate is the radius of the pile increasing? So Shaywa, what would that be? At what rate is the radius? What do they want? Yeah, they want dr/dt. dr/dt. So at what rate, as you drop more and more sand, your radius is going to get bigger and bigger. So at what rate is the radius of the pile increasing 4 minutes after it began pouring? So when time is equal to 4 minutes. Okay, so we need a formula that's going to relate volume with radius. So first of all, what's the formula for volume, did we say, of a cone? Pi r squared h. Okay, so this relates volume and radius, but can we somehow get rid of height? Because if I implicitly derive this, I'm going to have dh dt, and I don't know what that is. So does anybody know how we could get rid of height? By using something to do this? So height could be replaced with diameter, but then I don't want to take the derivative of the diameter. The diameter is 2r, yes. So you guys, diameter is 2 radii, is what the diameter is. That's equal to the height. So the diameter is equal to the height. I want to get rid of this height, right? And I don't want to put d in here, but I know that diameter is 2 radii. So what we could do is we could take height out and we could put in 2r's. So volume is 1/3 pi r squared. Height is 2 radii. Okay. Volume is equal to 1/3. No, this is going to be 2/3. Pi r cubed. Is everybody good with that so far? So 2/3 pi r cubed. Let's differentiate both sides with respect to time. And we're going to have to do something with that hint. Okay, so dv over dt is equal to, according to power rule, if you bring this down, I would have 3/3 would cancel, so I'd get 2 pi r squared dr dt. Okay, so this is what I have so far. I'm looking for this. I have this, but I don't know what the radius is. So I've got to do something with this time. So here's what the hint says. It says find the volume of the conical pile after 4 minutes. So let's see what that would be. So volume of pile at 4 minutes. Somehow we're going to figure something out, and we need to get radius is what we're missing. So volume of pile at 4 minutes. Okay, so you guys, the rate at which this pile is increasing is 0.5 meters cubed per minute. So at 4 minutes, the volume of the pile, the sand is being poured at 0.5 pi meters cubed per minute. That's how much sand is being poured, 0.5 pi meters cubed every minute. After 4 minutes, okay, so after 4 minutes, I could figure out sort of what the volume is at 4 minutes. So volume is equal to, what's half times 4? So 2 pi meters cubed. Okay, so 2 pi meters cubed. Now, I still don't know what the radius is because that's what I need to figure out what the radius is. So what I'm going to do is I'm going to take out volume. And what was the formula for volume? So volume up here. So you guys, right here, volume, we had 2 over 3 pi r cubed. So like that's what the volume was, right? So volume is 2 over 3 pi r cubed. So take V out and let's put in what the volume is, 2 over 3 pi r cubed. So take this out. Volume is 2 over 3 pi r cubed. That's equal to 2 pi. And then we're going to manipulate this to get what r is equal to, what the radius is. So how we would do that, I've got a pi on each side of my equal sign, so I could cancel out my pi's. I want to get r by itself, so I'm going to get rid of this 2/3 by reciprocating it. So I'm going to multiply this side by 3 over 2 and multiply this side by 3 over 2. And then 2 over 2 over here will cancel. And this will cancel. So now I've got r cubed is equal to 3. And I need to get r by itself. So I'm going to cube root this side, and I'm going to cube root that side. So the radius is the cube root of 3. So now going back up here, dv dt, they gave me. It was 0.5 pi. So 0.5 pi is equal to 2 pi. R, I just calculated. R is the third root of 3. And then I'm trying to find dr dt. What's that? Yes, thank you. That guy needs to be squared. Okay, so from here, a pi and a pi will cancel. So cancel those. And I need to get this by itself. So I'm going to divide both sides by this 2 and then the third root of 3 squared. So that would leave me with 0.5 over 2 and the third root of 3 squared. And that is equal to dr dt, the rate at which the radius is changing with respect to time. Now, one other thing I could clean up in here is I could clean up, if I wanted, this 0.5 divided by 2. So let's just see how this would clean up. 0.5 divided by 2, that's 1/2. Like, so 0.5 is 1/2 divided by 2. What would it be? It'd be 1/4. You're going to multiply by the reciprocal. So like this can be cleaned up to be 1/4. So the rate at which the radius is changing with respect to time is 1/4. And then it was the third root of 3 squared. And it was radius, and radius was in meters per minute. Okay, that's all we could figure out from there. I will get you your worksheet, and then I'll show you the solutions.